Hello friends, I welcome you in lecture number 5 on theory of probability. In this lecture we will discuss two problems on conditional probability and multiplication rule of probability. We have discussed about conditional probability in previous lecture and we just recall the definition of conditional probability. Suppose we want to find out conditional probability of event B given that event B is affected by the occurrence of event A, then we know that this conditional probability is given by the ratio of probability of A intersection B and probability of A, and here probability of A is non-zero, that is event A has occurred first and event B depends on event A, therefore probability of B given A is conditional probability. And from this, if we are interested in the joint probability of A and B, then we have this multiplication rule of probability. So both are equivalent. We can derive multiplication rule from this definition, or we can write this definition from this multiplication rule of probability. So we will apply both of these formulas whenever we have dependent events, that is one event is affected by the occurrence of another event. So we consider this example first. It is given that probability that a communication system will have high fidelity is 0.81 and the probability that communication system will have high fidelity and high selectivity is 0.18, and we have to find the probability that a system with high fidelity will also have high selectivity. So if you observe carefully, here they are talking about system with high fidelity and system with high selectivity. They are discussing about two features of communication system, that communication system will have high fidelity, that is one feature. Another feature is communication system will have high selectivity. So here we have to find the probability that system with high fidelity, that is it is given that system has high fidelity, and we have to find that if system has high fidelity, we have to find the probability that system will also have high selectivity. So here from this we can see that this event, that communication system will have high selectivity, depends on the event that system will have high fidelity. So we will define this as event A, that event A is system with high fidelity and event B will be system with high selectivity. And if we consider these notations, then here we have to find the probability that B given A. B means system will have high selectivity and event A is system will have high fidelity. So here you can see from this line that what is the probability that a system with high fidelity, that is it is given that system has high fidelity, therefore we write A here, and if system has high fidelity, we have to find the probability that system will have high selectivity, that is we have to find the probability that B given A. And what is given? It is given that system will have high fidelity and probability of high fidelity is 0.81, that is we are given the probability of event A, that is system with high fidelity is 0.81, and we are also given that here we are given that, and the probability that it will have high fidelity and high selectivity is 0.18, that is we are given the probability of event A and B, that is we are given the probability of A intersection B, system with high fidelity and with high selectivity, and probability of that is 0.18. 0.18 is the probability that system will have high fidelity and system will have high selectivity, and using this we have to calculate probability of B given A, and that is easy. We just have to use the definition of conditional probability, that is we have to take ratio of these two given quantities, but we have to write systematically. First we will define that suppose event A denotes that communication system with high fidelity and communication system with high selectivity. This event is denoted by B, and then we write that whatever is given, we are given that probability that communication system will have high fidelity is given as 0.81, and we are also given that system will have high fidelity and high selectivity. Probability of this is 0.18. Now we have to find the probability that system will have high selectivity given that system has high fidelity. This we are asked to find out. If you read the last line, you have to find the probability that a system with high fidelity will also have high selectivity, and this is nothing but in terms of our notations, high selectivity is denoted by capital B and event A is system with high fidelity, and by the definition of conditional probability, this is probability of A intersection B divided by probability of A. We are given the values of these two numbers 0.18 and here 0.81. 0.18, that is 18 by 100, and this is 81 by 100, so 100 will get cancelled. Here we can cancel 9 and we are left with 2. Here we are left with 9. So this is the required probability. Probability that system with high fidelity will also have high selectivity is 2 by 9. So this is simple application of the definition of conditional probability. All you have to find is that first you check that which probabilities are given and you define your events accordingly, and then use the definition of conditional probability. We move towards the next problem. Here we are given that the supervisor of a group of 20 construction workers wants to get the opinion of 2 of them, which are selected at random, about certain new safety regulations. If 12 workers favor the new regulations and 8 are against them, that is 8 are against the new safety regulations, what is the probability that both of the workers chosen by the supervisor will be against the new safety regulations? So from this, after reading this question, you must be clear that here they are talking about some safety regulations, and for that there are 20 construction workers group and supervisor wants to get the opinion of 2 workers which are randomly selected out of these 20 workers. Now it is given that out of 20 workers, there are total 20 workers, and it is given that out of 20 workers, 12 workers favor the new regulations. So 12 workers are in favor of new safety regulations, and it is given that 8 workers are against the new safety regulations. There are total 20 workers, 12 are in favor of new safety regulations, 8 are in against new safety regulations. Now supervisor wants to take the opinion of 2 workers out of these 20 workers. Supervisor wants to take the opinion of 2 workers which are selected at random out of these 20 workers, and he after that we have to find the probability that both of the workers selected by the supervisor will be against the new safety regulations. Again I repeat, supervisor wants to take opinion of 2 randomly selected workers out of 20 workers. In 20 workers there are 12 workers in favor of new safety regulations and 8 workers are against the new safety regulations. So first supervisor will consider one selection randomly, he will take its opinion. After that he will again select another worker randomly and he will take its opinion about the new safety regulation. So we have to find the probability that this first selected worker and second selected worker both are against the new safety regulations. We have to find the probability that first worker as well as second worker are against new safety regulations. So here how we will define the events. We will first consider event A as first selected worker, or simply first worker is against the new safety regulations. First worker selected out of 20 is against the new safety regulations, that I denote by event A, and I denote second event by B, and that is for second worker. Here also I consider that second worker is against the new safety regulations. New safety regulations. I define A and B in this way. And what I want to find out? I want to find the probability that both workers are against new safety regulations. That is, worker selected first is against the new safety regulation and second worker is also against new safety regulations. That I want to find out. Now to find out this probability, we will use multiplication rule for probability. We know that this is given by probability of A times probability of B given A. So first I have to determine these two probabilities, and then I will be able to determine this probability that both workers will be against new safety regulations. Now first we observe that if we want to find out probability of A, then here we have to find the probability that first worker is against new safety regulations. Now there are total 20 workers. So first we are selecting worker randomly, one worker randomly. That we can do in 20 ways because there are 20 workers. And our event is that first worker is against the new safety regulations, and here we have total 8 workers against the new safety regulations. So outcomes in favor of event A are 8. Okay, we can select the worker which is against new safety regulations from 8 workers in 8C1, that is equal to 8 ways. So probability of A is 8 by 20. Now whatever opinion we have taken from the first worker, we are not going to consider that worker again. So out of 20 workers, I have taken the opinion of first worker selected in first trial at random. So now in the sample space for event B, I am left with 19 workers, because for worker selected in the first trial, for whatever worker I have taken the opinion in the first trial, I will not count that worker here. So here sample space is reduced to 19 because here we are considering opinion of second worker also. So sample space for this second event will be having 19 workers. And here also I am interested in the event that second worker is against the new safety regulations. And here we can see there are 8 workers who are against the new safety regulations. And in event A, we have considered that first worker is against the new safety regulations. So this number will also reduced by 1. Now we will have 7 workers which are against the new safety regulations. Therefore, this is going to be the probability of B given A, because event B is affected by the occurrence of event A, because we have taken first worker against the new safety regulations as event A, and that affects the occurrence of event B. Here we can see that sample space is reduced to 19. So this is probability of B given A, and now we are interested in the probability that both workers are against new safety regulations. Both workers are against new safety regulations. So this is equal to probability that first worker is against new safety regulations, second worker is against new safety regulations. So that is nothing but probability of A intersection B, and by multiplication rule of probability, this is probability of A times probability of B given A. Probability of A is 8 by 20 and probability of B given A is 7 by 19. And here we can cancel out 4 into 2 8, here 5 into 4, and here we have 14 divided by 95. So this is application of this multiplication rule of probability. Now if you wish, you can do the same problem using classical definition of probability also. This is one way to solve this problem using multiplication rule of probability. But suppose I want to use definition of probability to solve this problem, then here you can see there are total 20 workers and they are selecting 2 workers randomly. So if you consider the random experiment as to select 2 workers out of 20, then this is going to be the number of elements in the sample space. Now we define event E as these 2 workers selected randomly, 2 workers, both are against new safety regulations. 2 workers are against new safety regulations. So it is given that out of 20, 12 are in favor and 8 are against new safety regulations. So there are 8 workers who are against new safety regulations, and we are interested in the number of elements in favor of event E. So out of these 8 workers, we can select 2 workers in 8C2 ways who are against new safety regulations, and we are interested in the probability of event E. So that is going to be number of elements in event E divided by total number of elements in the sample space. And here you can see this is 20 into 19 divided by 2 into 1, and 2 in the denominator will get cancelled, and here we have 5, here we are left with 2, and answer is 14 divided by 95. So we are able to solve the same problem using definition of probability. And here to explain the application of multiplication rule, I have solved this problem using multiplication rule of probability. It is general multiplication rule of probability. Here events A and B are dependent events. So whenever we have this type of dependent events, we can use either definition of conditional probability or multiplication rule of probability to solve this type of problems. So this is all about this session. I hope you like it. Thanks for watching.